um, Web architecture, markup languages and other formalisms written using the syntax of XML. Here you can see a web architecture diagram. Web architecture focuses on the foundation technologies and principles which sustain the web, including URIs and HTTP. Now we are focusing on XML. XML in full extensible markup language, a document formatting language used for some World Wide Web pages. XML began to be developed in the 1990s because HTML, hypertext markup language, the basic format for web pages, does not allow definition of new text elements, that is, it is not extensible. XML is a simplified form of HTML, standard generalized markup language intended for documents that are published on the web. Like HTML, XML uses DTDs, document type definitions, to define document types and the meanings of tags used in them. XML adopts conventions that make it easy to parse, such as that document entities are marked by both a beginning and an ending tag, such as begin to /begin. XML provides more kinds of hypertext links than HTML, such as bidirectional links and links relative to the document subsection. Here you can see XML architecture. The browser is connected with the server through HTTP hypertext transfer protocol. Web browser, wireless application protocol browser, is connected with the server through WML, wireless markup language. And here standalone client is connected with the server through HTTP, RMI, IIOP, remote method invocation interface over the internet inter-op protocol, and JNDI, Java naming and directory interface. Here you can then XML is connected with the server, and again XML is connected with the server, and server is connected with the MIBP client through HTTP, and here you can see the communications is going through this path, here and here, into XML, and sometimes, and server is connected with the database. Here you can see anatomy of an XML document. You can see the declaration here. It identifies the document as XML. Note that mandatory XML version number 1.0 and the description of the encoding UTF-8 used by the document. XML documents can use any encoding provided that the XML parser used to process the document knows how to deal with the encoding. Document type declaration. It identifies the DTD tag vocabulary used by the XML document and the tag name for the root element car here. This vocabulary is stored in an external file with the .dtt extension, automobile.dtd, though it can also be inlined in the document. The document type declaration is optional and tend to be gradually replaced by another equivalent but more powerful mechanism called XSD schemas. The root element. An XML has one and only one root element called car here, and you can see elements here. An element is identified by the start tag and an end tag. If the element has no sub-elements, the syntax can optionally be abbreviated to one tag, as for the wheel element. Notice the trailing / in this case. Attributes. The start tag can contain attributes which are name and value pairs qualifying the element. Attributes names are unique within the tag scope. Attributes values appear within quotes. Body is the value of the attributes called name here. Of the part element. And characters. XML element can also contain free text. Entities. XML use entities to escape reserved characters or specify characters not supported by the document code page. The ampersand LT entity is used here to escape the less than reserved character. Comments. XML document can be annotated with comments. Other synthetic construct, C data sections, processing instruction, etc. can occasionally appear in XML documents. Here you can see XML code for a note as an example, and you can here you can see the display of the XML file as a note in Chrome browser. As an error example, we can consider XML parsing error, syntax error. Your feed is not well formed according to XML specification. All feeds must be well formed XML. In fact, IE7 and the RSS platform in Windows Vista only support feeds that are well formed XML. Now here we are considering other markups languages and other formalisms written using the syntax of XML, which are not presented in this diagram. As an example, we can consider EBXML, electronic business using extensible markup language, commonly known as eBusiness XML or EBXML, as it is typically referred to, is a family of XML based standards sponsored by SIS and UNCEFACT, whose mission is to provide an open XML-based infrastructure that enables the global use of electronic business information in an interoperable, secure and consistent manner by all traditional partners. Now we are focusing on XHTML, Extensible Hypertext Markup Language. XHTML is a part of family of XML markup languages. It mirrors or extends versions of the widely used hypertext markup language HTML, the language in which the web pages are formulated. Here you can see architecture of XHTML's modularization. The architecture of XHTML's modularization is simple. The basic framework of HTML modules enables the development of XHTML conforming markup languages. These new languages must use the basic framework and may also use other XHTML provided modules, other W3C defined modules, or indeed any other module that is correctly defined. Modules plug in together within XHTML framework to define the markup language that is task or client specific, but which is based upon the familiar XHTML structure. This new markup language is appropriate for the development of a portable XHTML conforming content. Documents developed against the new markup language will be usable on any XHTML conforming client. In many cases, the content will also be portable to existing HTML for browsers. XHTML does not require the use of specific markup language description format. Instead, it defines its modules using abstract prose and implements the abstraction using formats such as XML DTDs and XML schema. Each implementation places some structural requirement on the way in which modules can be plugged together. However, in general, it permits the definition of XHTML conforming markup language by merely taking a supplied markup language template and adding into that template references to the modules that are needed by the markup language. Here you can see these new languages must use basic framework and may also use other XHTML provided modules or other W3C defined modules or indeed any other module that is correctly defined. As an example, you can see the XHTML code here. This example used strict DTD, meaning that every single tag must be closed properly, all attributes, assigned values, etc. You can see the output here, sample output. As an example too, you can consider this code. Here this is about XHTML rendering in an ASP.NET website. Under the system.web element in your application's web.config file, add an HTML conformance element, and then set the mod attribute to legacy, transitional or strict. If no XHTML conformance element is defined in the web.config file, the default settings mod is transitional. As an error example, we can consider this following error. This page contains the following errors. Error on line 12 at column 1, extra content at the end of the document, missing end tags at the end of a document. The relevant browsers are Chromium 6 and Midori 0.2 to 0.4 and Safari 5. Now we are focusing on MathML. Mathematical markup language. MathML is a mathematical markup language, an application of XML for describing mathematical notations and capturing both its structure and content. It aims at integrating mathematical formulae into World Wide Web pages and other documents. It is a part of HTML5 and an ISO standard, ISO IEC 40314 since 2015. Here you can see an example of presentation MathML encoding of a simple mathematical equation. This is the equation and this is the relevant code here. As an example, we can consider this code segment, the segment for the mathematical expression a plus b squared. This example demonstrates a number of presentation elements. The first elements, one that is used a great deal is mrow. This element used to denote a row of horizontally aligned material. The material contains between the mrow and /mrow tag is considered to be an argument to the mrow element. Thus the whole expression here is contained in an mrow element. As previously noted, the almost all mathematical expressions decomposed into sub-expressions. These sub-expressions can in turn also be contained in the mrow element. For example, a plus b also contained in the mrow element here. M-fenced element is used to provide fences, braces, brackets and parentheses around formula material. It defaults to using parentheses. Note that the use of mi element for displaying the variables a and b, and mo element and the mo element for making plus operator. msup operate element is for expressions involving superscripts and takes two arguments in order. The base expression here, a plus b, and expression and the exponent expression here 2. As an another example, we can consider this code segment. Unfortunately, some browsers are not able to render MathML equations or only have a limited support. If you need more complex constructions, you might instead consider using a heavier MathJax library as MathML polyfill. To use it, just insert one line in your document header, this one. As an example, we can as an error example, we can consider this code segment. The error element displays its content as an error message. This might be done, for example, by displaying the content in red, flashing the content, or changing the background color. The contents can be any expression or expression sequence. In this code, the output of this code segment is here, unrecognized element, colon, and m fraction, semicolon, and arguments were and 1 plus 5 and 2. Now we are considering SVG, scalable vector graphics. SVG is an XML based vector image format for two-dimensional graphics with support for interactivity and animation. SVG specification is an open standard developed by the World Wide Web Consortium W3C since 1999. As an example, we can consider this code segment. This is the output. The rendering process involved the following. We start with the SVG root element. The doc type declaration as known from XHTML should be left off because DTD based SVG validation leads to more problem than it solves. Before SVG2, to identify the version of SVG for other types of validation, the version and base profile attributes should always be used instead. Both version and base profile attributes are duplicated in SVG2. As an XML dialect, SVG must always bind the namespaces correctly in the XML NS attributes. The background is set to red by drawing a rectangle that covers the complete image area. The green circle with a circle here with a radius of 8 pixels is drawn atop the center of the red rectangle, center of circle offset 150 pixel to the right and 100 pixel downward from the top left corner. The text SVG is drawn. The interior of each letter is filled with the white. We fill with white. The text is positioned by setting an anchor where we want the midpoint to be. In this case, the midpoint should correspond to the center of the green circle. Fine adjustments can be made to the font size and vertical position to ensure the final result is aesthetically pleasing. So this is the end output. As another example, we can consider this code segment. The most basic way to embed an SVG via an IMG element is to reference it in the src attributes, as you would expect. You will need the height and a width attribute, or both if your SVG has no inherent aspect ratio. As an error example, we can consider following error. Error on line 8 at column 93. Namespace prefix Inkscape for connector curvature on path is not defined. What this error suggests is that the file has Inkscape attributes without the Inkscape namespace being defined. Now we are focusing on SMIL, Synchronized Multimedia Integration Language. SMIL is a Worldwide Web Consortium recommended extensible markup language, XML, a markup language to describe multimedia presentations. It defines markup for timing, layout, animations, visual translations, and media embedding, among other things. SMIL allows presenting media items such as text, images, video, audio, links to other SMIL presentations and files from multiple web servers. SMIL markup is written in XML and has similarities to HTML. Here you can see SMIL 2.0 XML for web multimedia. Here we can consider this example, and SMIL is a simple but powerful XML compliant and markup language that coordinates when and how multimedia files play. An SMIL file extension .SMI can be created with any text editor or word processor, then saves output as a plain text with line breaks. An example of a simple SMIL file, this one, that lists multiple media files played in sequence is shown here. As an error example, a SMIL document with no body is reported as a parse error, and here body element is required. Now we are focusing on RDF, the resource description framework. RDF is a family of World Wide Web Consortium W3C specifications originally designed as a data model for metadata. It has come to be used as a general method for conceptual description or modeling of information that is implemented in web resources using a variety of syntax notations and data serialization formats. It is also used in knowledge management applications. Here you can see XML replaces HTML and allows the expression of structure. RDF allows the expression of semantics. Expressing in the HTML standard gave text processing applications a common way of expressing the structure of data, even when different document types had different structures. Hypertext markup language is one particular application based on HTML. Others include many document types defined for CALS initiative, for example. W3's new extensible markup language XML provides the same function as HTML in a simpler and more powerful way. Future text markup from W3C will be built on XML rather than HTML. This may even apply to the future versions of HTML depending on technical work on back compatibility and transition strategy. With regarding metadata, increasingly the web is being used for machine understandable content. XML's arrival is very timely for this, as it provides a common syntax for a large number of new data formats. Of these applications, many have more in common than simply being structured data. The data represent machine understandable assertions about objects on or off the web. This metadata will allow huge amount of information in databases and existing applications to be put on the web, not just for human browsing but for machine understanding, searching, reasoning and analyzing. Expressing semantics. The resource description framework RDF is a set of specifications which allow metadata applications to be combined and to operate with a common way of expressing the semantics which they share. RDF is a further layer on top of XML. Currently there is not only a large industry in applications to put information from legacy information system onto the web. There is also an industry in application which surf the web and program with some idea of how the web pages were automatically generated, retrieve the information and reconvert it into hard well-defined machine processable data. RDF will allow this long route to be short-circuited and allow programs to gather data directly. With benefit of experience, RDF makes a great step forward from specifications such as HTML and HTTP. These specifications have been extended significantly during their evolution to date. The process has been one of the experimental addition of new tags. The significance or importance of these new tags has never been evident to software not involved in the experiment, with the resulting danger of serious incompatibility. And RDF has the goal to allow documents to be written in a mixture of all standard vocabularies and specific new experimental or proprietary vocabularies, but with the well-defined way of knowing what is important, what can be ignored, and how old software can reduce or download an understanding of new vocabulary. This will hopefully allow powerful combinations of applications when, for example, documents can be made combined in a well-defined way of concepts, for instance from banking, engineering and legal vocabularies. The power of the web as an expressive medium will become the product rather than sum of the individual developments. Furthermore, by allowing experimental vocabularies to intermix with standard vocabularies without threatening the integrity of the system, RDF will give us surer and faster deployment path for new ideas, free from the need for so many standard meetings. With in transition, the plan is for W3's existing specifications such as PICS 1.0 written before XML and RDF to make the transition to a 2.0 version defined in terms of RDF and therefore XML. This will make possible to mix PICS labels with information about privacy, for example, from P3P project, which will use RDF. Many new applications will like P3P by directly built on RDF. The consortium encouraged existing applications to make the transition to RDF in order to take advantage of extensibility and power of combination with other applications. We can consider this code segment as an example. An RDF graph is given here, where the nodes are represented as ovals and contain their IRIs where they have them, and all predicates arcs are labeled with IRIs where they have them, and all predicates arcs are labeled with IRIs, and string literals nodes have been written in rectangles. If we follow one node predicate arc node path through the graph here, the left hand side of the graph correspond to the node predicate arc strips. Node with IRI http://www.w3.org/tr/rdf syntax grammar here. Then predicate arc labeled with IRI http://example.org/terms editor. then not with no IRI, and predicate arc labeled with IRI, http://example.org/terms/homepage, and not with IRI, http://purl.org/net/DAGOBE. The RDF XML, in RDF XML, the sequence of 5 nodes and predicates arcs on the left hand side of this figure correspond to the usage of 5 XML elements of 2 types for graph nodes and predicate arcs. These are conventionally called node elements and property elements respectively. In the stripping shown here, the RDF description is the node element used 3 times for 3 nodes, and EX editor, EX colon editor, and EX colon dot home page, which is not shown here in this code segment, are 2 property elements. The graph consists of some nodes that are IRIs and others that are not, and this can be added to RDF XML using the RDF colon about attribute on node elements to give the results. Adding the other 2 paths through the figure here graph to the RDF XML gives the result this one. This example fails to show the blank node is shared between 2 paths. So in this example we are considering DAGOBE and full name, EX colon full name, here. This is a segment of the full code. You can see with here RDF colon about and some nodes that are RIs, and this can be added to RDF XML using this RDF about. Now we can consider this example as example 2. Here you will see the standard W3 org namespace, http www.w3.1999/02/22 RDF syntax ns hash. This namespace tell any machine reader that enclosing document is an RDF document and that the RDF tag reside in this namespace. This namespace and RDF node forms the root of all RDF documents. An RDF document can contain more than one statement. Here in RDF, the RDF colon description tag simply means I'm going to describe something, a subject, and I am giving it a unique ID, http://en.wikipedia.org/wiki/Oxford. There's no point of saying you are going to describe something. Give it a unique ID but not describe anything about it. RDF statements describe the characteristics of their subjects using properties or predicates in RDF terminology. As an example 3, we can consider setting up an RDF environment. For DB version 10.1, fix pack 1 and earlier download ARQ package version 2.8.5 from http://project/gina/files/arq/arq stroke 2.8.5 download the commands logging 103.jar from the Apache Commons project. Place this jar in the install path /sqllib/rdf/lib directory. Then cd install path /sqllib/rdf/bin. Then set the class path equal install path /db2.zc4.jar % class path %. Now you can run db2 rdf command line utilities in this command prompt. As an error example, we can consider RDF parsing error. The feed uses an RDF format RSS 0.90, 1.0 or 1.1, but it is not valid RDF /XML. Now we are considering PICS. PICS, the platform for internet content selection, PICS 96, PICS SYS 96 is a system for associating metadata, PICS labels, with internet content. PICS provides a mechanism whereby independent groups can develop metadata vocabularies without naming conflict. The syntax of a PICS label is very compact and does not use any of the subsequent web technologies such as XML and XSL, RDF, the resource description framework, RDF 99, RDF SCH, RDF schema 00. Provide a label for representing metadata that is even more general than PICS, with more expressive power and uses XML syntax. The goal of RDF was to permit the mechanical translation of PICS metadata into RDF form. This document represents one possible mapping of PICS into XML RDF. In this diagram you can see this is a different representation of the same web architecture diagram. You can see PICS here it mentioned HTML here instead of XHTML, and here you can see the PICS here. As an example, we can consider this code segment and a label list for two documents using the example rating system from PICS rating services and rating system might be as above. In all examples, the spacing and indentation is provided for readability. The specification treats multiple white space characters as if they were compressed into a single space. As another example, we can consider embed a PICS label in an HTML document. Here we can see meta and HTML, HTTP, equi, PCL label and contents. PICS contents are here. Now we are considering P3P. P3P enables website to express their privacy practices and enables users to exercise preferences over those practices. P3P compliant products will allow users to be informed of site practices in both machine and human readable formats, to delegate decisions to their computer when appropriate, and to tailor their relationship to specific sites. Site practices that are compatible with the user's preferences can, at the user's options, be accessed seamlessly. Otherwise, users will be notified of site practices and have the opportunity to agree to those terms or other terms and continue browsing if they wish. Here you can see a component OWL ontology, RDF policy and RDQL rules interactions. Here you can see an overview of RDF policy and SWAPPEL rule set, then describe how they are used within typical interaction. Note that the concepts used in both RDF policy and in the SWAPPEL rule sets RDQL query are defined by OWL ontology. This diagram shows how these standards are used within experimental implementation of P2P. In short, the OWA ontology specifies the concepts that may be used within any RDF P3P policy in much the same way that the P3P 1.0 XML schema specified the way XML tags may be used within P3P 1.0. The important difference is that the OWL ontology makes statements about the semantics of the concept used and is not purely synthetics. Using OWL ontology, RDF P3P policies are written which are then linked to resources using P3P policy reference files. We have not specified an RDF syntax for policy reference files. Because we do not think the semantics of this are complex enough to justify using RDF. The lighter weight XML syntax is adequate in this case. User agents define preferences using SWAPPEL, which define a set of rules for matching against a resources RDF P3P policy. These rules perform RDQL query on the policy, and if they match, the behavior for the rule is executed. So this is the RDF query section, RDQL query section, and behavior description. So here OWA P3P ontology defines the language used here. It's going through RDF privacy policy and SWA PPL, and policy editor can access RDF privacy policy and the OWL P3P ontology, and RDQL query language specification and SWA PPEL schema defines the rule syntax for SWA PPEL user preference rules, and here resource event here, and policy query RDQL here, behavior description is here, and then RDF privacy policy and SWA PPEL is moving as an input to SWA PPEL decision engine, and then it decide behavior description. We can consider this code segment as an example. It's an RDF representation of the policy reference. So as an example, we can consider as an error example, we can consider ERR stroke is if the P3P message that was received was syntactically invalid or semantic garbage. It can be sent by server or client. There are now we are moving into other RDF applications. There are other RDF applications. Here you can see FOAF. FOAF is a machine readable ontology describing persons and their activities and their relations to other people and objects. So you can see name and nose and things, and this is another diagram. The in reply to is there, and some sample applications for the validation. We can use W3C RDF validator, ontology RDFS OWL log, semantic web services for the query RDQL LG squish for logic rules, CWM RASCR FACT when used with the translator. For data services, Gina/Joseki and TAP semantic search, 3stop. For filtering and aggregation, NewsMonster PICS. For privacy and digital rights, P3P, Creative Commons, and more. FOAF and FOAF CORP, Anotia RSS 1.0, WordNet, Music Brain Z, Serpa, RDF iCalendar. For as an example, we can consider RDQL. RDQL or RDF data query language is a computer language, specifically a query language for databases able to retrieve and manipulate data stored in resource description framework format. This is the end of the presentation. Thank you very much for watching the presentation.